Alright, so in this lesson we'll be going through, and I believe this is operating system synchronization, and in the concepts part where I discussed the main ideas, what we did was to say, going through this very quickly, we had a scenario where we said a banker was going to read a balance of an account, calculate a new balance and store it. So I'm going to be using this to demonstrate how Java handles synchronization. Right. So let's look at some Java code. Right. So we start with a banker. So this is a banker class, and what it does here is the constructor has the name of the banker, an account object, and an amount, and this is the amount the banker would be adding. So for example, the banker, when he has to do a job, would say, I'm going to get the balance, that's it, I'm going to add an amount to the balance, store it, and then save it to the account object. Let's look at the account object, a very simple object actually. You can see what the account does. It says, initially says balance is 0, but there's a method you can call that just adds an amount to the balance. But the bankers can do this themselves as well. It doesn't really matter. I'm just using this to illustrate. Now, my main, let's look at what the main does. What I've done here in the main is I'm going to create a number of bankers. In this case, 10,000 bankers. And each banker is going to deposit 100 units. So I have a banker array and a thread list. In the first example, I am not going to be using classical threading. All I'm going to be doing is, after I make the bankers, so this is a loop that counts how many bankers. They are all sharing one account. So this account is shared. So this is like a real world scenario. You go to a bank, you may be depositing money into a company account, someone in another place is depositing money, removing money, but we're saying if everything goes well perfectly, remember, no preemption. No preemption means nobody is stopped from doing work. Once you go in, you're just doing your work, nobody stops you. If that is the case, then we just call run. So we're just looping through all the bankers and say, everybody run, run, run. And once we run them, we should be able to print out the result. Right. And the result printing, this is done. You can see here we say the total number of bankers, the total deposits, and so when we run this, we expect the result to hold. So I kept a simple one. I'm going to run this. It takes a few minutes. I hope it doesn't take too long. Okay, so I think I'm missing something. Alright, so we said there were a few techniques: Mutex locks, semaphores, and monitors, and we're going to see how we're going to use this in our code. So I'm going to start off with the locks. Right. So if you use Java, so there is a reentrant lock. There are many other locks. So I'll just use autocomplete. Read-write lock. There are quite a few here. So there's condition lock, read-write lock. You can read up on how to use this. I'm just going to be using reentrant lock. There's read-write lock as well, but that means most of the things you're doing, you can just apply them. Java has them. You can use or any other language. C#, I could have used any other thing. Python, PHP, whatever language. I am sure you'd find a package that does locks. So first thing I did was I went to the banker class and added a lock object. So that means that there's an account and a lock. And what you see with the lock is, before I access a shared resource, I say account.lock. And when I'm leaving, I say account.unlock. So I let go. So that means when I'm entering, only one person is allowed to be in here. And when I'm leaving, only one person leaves it, and then the other people can go in. Now, if you look at my main, same code. But the only thing here is now I create a lock and I assign to each banker the lock. So now all the banks have access to the same lock, they have access to it. And let's run this to see how it goes. summing up the numbers. Remember, there are 10,000 bankers, each depositing 100. And the result is correct, right? Now, there are some people who think that it's just going to be about the locks, but remember, you need the whole package. Let me comment out the join and look at what happens when we are not waiting for the work to be done before we try and print. The result is wrong. So yeah, you need a few skills and techniques. So you're putting all of these together. So it's not just, oh, it's just the locking. No. There's also coordination. Coordination here meaning someone needs results from someone else, he has to wait for it before he proceeds. That's what the join is doing. Right? There are other ways to do this, many other things like signaling on objects and so on. Right? So let's go to the next approach. So that is with the semaphore. So let's look at what semaphore looks like. Very simple actually. There is a semaphore class. Wow, pretty easy, right? So remember we said a semaphore, and the Java one is called acquire. How do you get one of the items? So with a semaphore, so just review, because I think that's the only one that's a little bit different from what people think of. For a lock, people know I grab a lock and I'm the only person who can go in. For a semaphore, that means I have a set of keys, or some people say a set of tickets, a set of locks, and that means I can have more than one item in a place. So it's up to the developer or the programmer, engineer, architect to say how many things are going to be allowed to be in there, right? So in the case of the banking scenario, I still want one person to be in there. So even though I am using a semaphore, I still say try semaphore to acquire and semaphore release, right? So that means similar to lock and lock, but you acquire, that means I get one item and I can release it. Now you can also look at the code for the initialization, and what I've done here is please note that in the banker, so I'll scroll up quietly, slowly perhaps. In the banker there's a semaphore object that's now shared, right? If you scroll down to the back, when I'm setting them up, everybody has a semaphore, so every banker gets a semaphore, right? And importantly, note the semaphore is initialized with an integer. So remember I said this is counting, meaning I can have, it's like a lock. Now unlike just a lock with one item in there, I can have a lock with two items. So let me save this and run with when semaphore is 1, and of course I am doing join at the end, so you know that this code should work. So let's run this. This is semaphore is 1, it's running. Okay, there you go. This works. 1,000, 100, and 10,000 and 100. I have 1 million. That's my total. Now, what if semaphore were 2? And I'm not going to do this all the time, but I'm just going to show you that the semaphore object right, there are many methods in there. Right, there is available permits, and it says returns the current number of permits available in the semaphore. So that's the Java documentation. So it means even though it's like a lock, you can find out how many locks do I have. Right, so this is really interesting, in that it means that the idea of a semaphore is it won't just be one item. So depending on the programming scenario, how many people do you want in this section? As I said, sometimes you want more than one item in the section. It's cool, it's possible. Some scenarios do allow that, and sometimes you want just one item. A semaphore actually can handle both the mutex scenario and more than mutex scenario. So if we've made the semaphore item 2, what happens when we run this? So let's run it and see. The result is wrong, right? And I believe the result is wrong because we are allowing more than one person into the region, and usually the more people you allow into the more messed up, the further away you go. Okay, so this isn't too bad. So it means that if I had an infinite number of semaphores, it's almost like not having a lock, right? Because remember, the more semaphores, the larger the initial value, the capacity of the semaphore, the more people you're allowing in there. So if I say capacity 1, that means only one person is going in there. So let's run this, and in that case, my result is correct. It's come very soon. There. Right. So at the end of this, that means that we have gone through how Java implements locks, semaphores, and monitors, at least the basics. I asked people to go through Java. Oracle has a tutorial online. You can just search for it. You can say Oracle, I think it's called concurrency tutorial, threads tutorial. It goes through all of these, some of the issues. There are other things that as a developer you can look into, such as having thread pools. A thread pool just means that instead of having one thread handling one item, you can have a group of threads handling a group of work. You can code it yourself. Some people do this because they want to control everything, but note that there are actually methods or systems, frameworks that have been developed, libraries that do this. So make sure you take a look at the documentation. So thank you very much for watching, and that means at this point we have completed a significant part of synchronization. What does remain, of course, I said, is read up on what dining philosopher means, find out what bounded buffer means, and I'll try and just hint at these. The dining philosopher was about a set of diners sitting down. You can say maybe 5 of them, and between each pair of people is a chopstick. And what they're trying to do is, if they are going to be eating, one person can't eat with a single chopstick, so they have to grab one chopstick from each side before they eat. The bounded buffer problem is a different kind of scenario, and what that means is, so when we say a buffer, that means there's an area where you can store information, and bounded buffer would mean there's a limit to how much information is stored. Now, if you consider that someone is putting data into the buffer and someone is pulling data from the buffer, then it means that when the buffer is empty, so you can think of, for example, you're playing a YouTube video and it shows a buffering thing on the seek part, and so that means so long as it doesn't have video to play, it just keeps moving. When it hits the end, it stops. But when the buffer gets more data, then the video can keep playing. If you live in a country where your internet is super fast, you have no idea what that means. But if you live in a country where your internet takes a while, that's what buffering would do, at least in the browser, playing a video. But it can also happen in other cases. Maybe you have a database management system and results are being printed to screen. The results are being computed by your server process and someone else is pulling to the screen. That means it puts data into the buffer, the data is picked up and then sent to the screen. And bounded buffer just means that if there's a limited space for storing the temporary information, it means when the information is filled up, the person who is putting into the buffer has to wait until the buffer is emptied. There's also the producer-consumer problem, which is similar. Producers are creating items, consumers are consuming them. But if there's no item to pick up, the consumer will not be able to proceed because the producer has to produce items. If the producer were putting items into a buffer for the consumer to pick up, that would mean that the producer should pause and wait while the buffer is full, and should wait until the buffer is empty before putting items in. Right. So these are all just classical problems. Peterson's solution, sorry, you should take a look at it in the text. It's really interesting. It uses integers in a clock fashion, like modulo, like a clock face, and simply tries to give each person some priority to know that they will be able to enter the critical section. That's just brief, very brief summary. We'll look at that a little bit later, maybe in class. So please take a look at all of these, try the code. Thank you very much. There's one more case I needed to cover, and that is the synchronize method. So we are keeping things the same. This is synchronize. Well, it's like a monitor, more or less. And what I'm doing is, instead of using locks or anything, synchronize works a bit like a lock. So you can see all I do is I say synchronize, and I give it an object. For example, that means the account specifically, and nothing else changes, more or less. It's the same code, but the only thing I'm doing is I'm keeping this method here saying synchronized. So this is what Java has. That's like a monitor, right? And so you can see what we said about monitors is it's almost automatic. You don't have to say lock, unlock, and so on, but you need to pay attention to the object that you're using. So synchronize would automatically use something for locking, and in this case we are using the account for locking. Let's run this and see how it behaves. So you can see the synchronize works very well. So let me use another thing. So for example, instead of this .account, let me use this just to show you don't just use things, think about them critically. So let's do another one where we're synchronizing on the banker, one banker. Each banker synchronizes on himself. So you see this is wrong. And what I was saying was, usually when you're doing synchronize, it's going to try and lock something. So that means the banker himself is doing a lock. It's just like every banker has a key, and every banker is keeping his own key. That's how the lock is working. And in this case, I get the wrong thing. Now what I'm going to do is I'm going to do a different type of synchronize. What if someone said, well, I've heard that synchronize, so I'm going to make a method. So I'm going to make a different one, like public void synchronized do work. Right, so this is trying to, oh sorry, it's this. Alright, so someone decides to make a method. The person has heard of this synchronize keyword and wants to use it on a method. So this time is going to call do work. So I hit debug by mistake. Let me run this again. Right, so again, that means that all the bankers, the way that Java synchronized methods work is, this would mean that all the bankers are, when they are running, going to be using one of these based on an instance. So if an object exists and someone calls this method, only one person may be using that method on the object. This does not solve the problem. Let's use another approach. Now, keep in mind that you can combine, for example, I can do, even though this wasn't working, I can decide I want to do synchronize this .account. This confuses people sometimes. I don't know why, but it does. So in this case, I have a method which is not synchronized, but before I use it, I call synchronized. More or less making sure that anytime this method is being used indirectly, I am synchronizing it. Now if I do this, I think this would also fix the problem, because it means that before accessing the shared parts, just let it run. Yep, works. I am synchronizing. So this is another way, or the last, well, hopefully good way to do this. That means, remember I had a method here called balance change by account. Remember accounts, I could call right, so I can call the method that is within the account. Now some people may say, well, maybe if I make a method for the account and I run it, then that means I'll get the right answer. But I'm going to show you that that doesn't work. That doesn't, right? So the only way to solve it is synchronized. That's a solution. There, right? This part went by very quickly. You can scroll down, take your time, and mimic the code. I'm just going to scroll up and down so you can see what the code is doing. You can type this out yourself and see how it goes. I think I'll try and share this on the video as well, right? But this is more or less the different ways you can solve synchronization problems using any of the above mentioned. Thank you.